And we're back, folks. This is the review video day uno. Let's get it started. All right, let's do number one here. Page. Come on. I don't want this to go so slow here. Come on. Where are you at? There it is. Okay, went there. Find f of 1, f of negative 2, f of x is equal to 3 when x is what, and f of x equals 0 when x equals what. Find an interval where f is increasing, state the domain and range of f, sketch the graph of negative f of x on the same graph. All right, so what is f of 1? Somebody tell me, what is f of 1? F of 1 is what? 3. What is f of negative 2? Negative 1. Okay, if f of x is equal to 3, what's x? Positive 1, yeah. The y value being 3, when does that happen? At what x value? It happens at x equals 1. If f of x equals 0, what is x? Yeah, somewhere right here, right? You know, negative 0.75. Okay, I would really accept anything from like negative 0.6 to negative 0.8, something in there. What's my interval where x is increasing? What's my interval where x is increasing? Negative 2 to 1. Yeah. And you can assume, unless there is a clear open circle, that it is included. Right? You can assume, and that's from here on out. If it's not a clear open circle, you assume that it is closed on that interval. So negative 2 to 1. You know, if there was a case where maybe this would vary even more and there's multiple intervals where it's increasing, you just pick an interval, okay? Pick an interval where f is increasing. What's the domain? Negative 2 to 4. Negative 2 to 4. And what's the range? Negative 1 to 3. Good. Sketch the graph of negative f of x on the same graph. Now, what is the transformation? What is negative f of x? Reflection across the x, right? Reflection across the x. Okay, so that means this point's going to stay. Oh, sorry. That's reflection across the y. That means this point is going to stay. This point is going to flip up here. This point, since it's 1, 3, is going to go 1, negative 3. This point here is going to flip down here, and this point here is going to be there. So, curve up, apex, gradually down. There it is. Okay, questions on 1? Let's take a look at number 2. Okay. So very similar to the one on the take-home quiz, right? I should give you a 2x squared. Jeez. How dare I? All right. Again, you will be given the difference quotient. That's not something that I'm going to make you memorize yet, at least. So we have f of a plus h. So 2 times a plus h squared minus 5, a plus h plus 1, minus the quantity 2a squared minus 5a plus 1, all divided by h. Watch out. I still have some people saying, wait a sec, I thought things would cancel. And the reason why it's not canceling is because you didn't put it in parentheses and you didn't distribute that negative when you're subtracting there. Got to remember that's subtracting all of f of a. All right, here. So we got a plus h squared. Well, a plus h squared is a squared plus 2ah plus h squared. So when I distribute the 2 in, that's going to be 2a squared plus 4ah plus 2h squared. Distribute the negative 5 in, that's negative 5a minus 5h plus 1. Let's distribute the negative in. Minus 2a squared plus 5a minus 1, all divided by h. All right, favorite part of these problems. Okay, we got a 2a squared and a negative 2a squared. I've got a negative 5a and a positive 5a. I've got a positive 1 and I've got a negative 1. Anything else? Nope. Alrighty. So that's going to leave me with a 4ah plus 2h squared minus 5h. And how convenient, everybody's got an h. So they all go away. Oh, yikes. So I've got a 4a plus 2h minus 5. And again, order doesn't really matter there. 2h plus 4a minus 5. Whatever. Alrighty. Any questions on that one? We've done that a lot. Hopefully we're getting better at that. And again, you can expect the types of problems that you see on the practice test to be on the test. Like, for example, I know in the homework, didn't we have some ones that we had to do rational like that? Ooh, those were gross, right? Yeah, I'm giving you a polynomial here, so that's what you can expect, at least the same difficulty level. All right, so let's do, number 3. People always hate this one. Spoiler alert, it will be on the test. It's on the practice test, so you better know how to do this. All right, state the domain of f of x and identify any holes or asymptotes. Can somebody tell me what restricts the domain in a rational function? What restricts the domain in a rational? The denominator, right? The denominator restricts the domain in a rational. So what I want to do is I'm going to take the denominator and I'm going to say, well, this denominator cannot be 0, right? That's the restriction on the domain. The denominator cannot be 0. All right, now everybody's favorite, let's factor this. Now, you may be thinking, wait, I got an x to the 4th and an x squared. Yeah, that doesn't matter, it's separated by 2. I can still factor this down. Okay, I've got an x to the 4th, x squared, then nothing. I can factor that. That's going to leave us with, okay, what are the factors of 36 that add to get to negative 13? Negative 4, negative 9, right? So that's going to be x squared minus 9, x squared minus 4. X squared minus 9, x squared minus 4. All right, well, guess what? I can factor even those down. So x minus, oops, not 9 anymore, 3, because those are difference of squares. Okay, so my domain is that x cannot be plus or minus 3, or x cannot be plus or minus 2. I will be lenient on that. I will not make you do interval notation on that. Okay? I'm okay if you just give me that for the domain. I mean, if you really wanted to see the interval notation, okay. Negative infinity to negative 3. Negative 3 to negative 2. Negative 2 to positive 2. 2 to 3. 3 to infinity. That's interval notation. And I should have put union symbols in between all of those. But... So I'm just going to let you say x cannot be plus or minus 3 or x cannot be plus or minus 2. All right. Okay, now, asymptotes. So that's the domain. Asymptotes. Remember that for any rational function, the vertical asymptotes are the easy ones. Right? Actually, I should do holes first, shouldn't I? Okay, let's do holes first. Because it looks like the vertical asymptote should be here. Looks like I should have 4 vertical asymptotes. But wait, look at the numerator. The numerator can be factored to this. You follow me there? That's the numerator. The denominator is all this. Do you see the things that can cancel? That's where the holes are. Remember, where you cancel are where the holes are. So there are holes at plus or minus 2. You don't need to give me the full coordinate. I'm okay if you don't give me the full coordinate. There'll be a time and place for that. But right now, I can just say that there are holes at x equals positive 2 or negative 2. Heck, if you wanted to, you could throw those back in the equation and figure out where they'd be. But you don't need to do that for right now. Okay, now that means that there are vertical asymptotes at the leftover, x equals plus or minus 3. The canceled pieces are the holes. The pieces that are still left on the denominator, those are the vertical asymptotes. Okay, now, thinking about it this way, where are the horizontal asymptotes? Now, remember, there are 3 rules for the horizontal asymptotes. If it's top-heavy, now what do I mean when I say top-heavy? Meaning the degree on the numerator is higher than the degree on the denominator. The degree in the numerator is higher than the degree in the denominator. There are no horizontal asymptotes. If it's bottom-heavy, meaning the degree on the bottom is higher than the degree on the top, which is the case here, the horizontal asymptote is at y equals 0. So for this one, the horizontal asymptote is at y equals 0. The last case is if it's equal. If the degree in the numerator is equal to the degree in the denominator, then you divide the leading coefficients. Divide the LCs. Okay. So if it were like, I'll put it on here because this is video. If it was like a 2x cubed plus whatever, and then a 4x cubed plus whatever. Doesn't matter what comes next. Look at my degrees. They're the same, right? So my horizontal asymptote would be at 2/4 or 1/2. Y equals 1/2 would be my horizontal asymptote for that one. Okay. So we know that there are holes at plus or minus 2. There's vertical asymptotes at plus or minus 3. And there's one horizontal asymptote at y equals 0. Okay. Again, holes come up where the things cancel. Vertical asymptotes are where the denominator still does not equal 0. Or where the denominator still equals 0. And then the horizontal asymptotes, you just got to follow those rules. Top heavy, there's none. Bottom heavy, it's at 0. And then if it's equal, then you just got to divide the leading coefficients. Okay, questions about that one? I know that pulled on a lot of prior knowledge. I remember that was chapter 8 in Algebra 2. You guys always hated that chapter. All right. Let's take a look at the next one. Given the piecewise function, sketch the graph and find. All right. So what'd you guys get for f of negative 3? What'd you guys get? I got negative 5. F of 1, what'd you guys get? 3, that's what I got too. And f of 4? 14. Okay. Watch out here. The one that may have tripped you up was B. You have to plug 1 into the bottom, not the top, because it's or equal to on the bottom. Okay. So that would be 2 times 1 plus 1. That's why it comes out to be 3 and not negative 1. Questions on those? Okay, let's sketch it now. I think I pulled over a graph. Yeah, there we go. All right. Okay, so again, I know the breaking point. You know what? I'm going to do this. I know the breaking point is at positive 1. That's where the line is going to change. Okay, I know that on the right side, for x is greater than 1, then it's going to be x squared minus 2. Now, this might be hard to visualize of what it should look like. So maybe if you want to, break the boundary and then erase away what you don't need. Like, for example, isn't this just a shift of the quadratic down 2 units? So I should really, if I ignored the boundary, look like this, right? And I really don't care what's going to happen on the left side. But this is only going to happen for x is greater than 1. So there. Now, should that be an open circle or closed circle? That one should be open because that does not have the or equal to. Please make it a clear open. Yeah, I had to kind of really examine your graphs on the take-home quiz to see if it was open or not. Please make it a clear open. Like mine looks a little weird, but I think it's because that black line's there. And then we have the 2x plus 1. Okay, that one should be super easy. Y-intercept of 1, slope of 2, up 2 over 1. Okay, and that one should have the closed circle on that. That's what that one should look like. It should, mine doesn't look like it curves a lot, but it's quadratic, so it should curve. Questions on that one? If I ever want you to graph, I will provide you a graph. Okay. There are some exceptions to that, but that does not come until chapter 4, till January. All right, let's keep it rolling. Number 5. Ooh, sketching the graphs. Oh, this is fun. Transformations. Yay, transformations. Positive association. Yay, transformations. Transformations. Yay. No?
Do it again.
Yeah. Transformations. Yay. Giving you a word and then yay. So now that when you think of the word, you just say yay. Yeah. All right, what are my transformations here? Down 2, good. Left 4. Down 2, left 4. So that means all you have to do is do down 2, left 4. Again, it's just a sketch. I'll provide you a graph, but I'm going to go down 2, left 4. Down 2, there. Now, is it widened or narrowed at all? No. Okay, so you don't need to make it any skinnier or anything like that. I go up 1, over 1, up 1, left 1. Yeah, that's good enough for a sketch. 2x cubed plus 1. Okay. My parent cubic should look like this. I know that's just a sketch, but that's what my parent should look like, right? You should have those in your brain. If I go 2x cubed plus 1, what's the plus 1 doing again? Up 1. So I know the center point should go up 1 unit. But what is the 2 doing? Vertical stretch, right? It's elongating it. So it's actually going to make it like squeeze right? By a factor of 2. It's going to take each x value and say this was at 1, 1. Say this green was at 1, 1. That's going to take it to 1, 2, right? I know it's also moving up 1, but that's going to stretch out those y values. What shape should? Oh, is this bell ring at 9:17?
Yeah.
Okay. Well, I know I'll have to start at number 6. What shape is this? V shape. Right 6 down, or sorry, right 6 up 2. Right 6 up 2. And there has been no transformation on the width or narrowness of the V shape. Right 6 up 2. There we have it. Okay. Again, so I will make a video of 6 through the end. You can watch on Monday. Test Tuesday, Wednesday.